Science often feels like a cathedral built on unshakable truths, with Newton as one of its master architects. But what if a tiny error, a single mistranslated word, has quietly distorted our understanding of the universe for centuries? Imagine a foundational law recited by generations, holding a secret that changes everything. This is not about overturning Newton, but about rediscovering a more powerful, elegant idea hidden in his original words. Our journey begins with Newton's, where a single Latin word may reveal a deeper, more dynamic vision of reality. Let's explore how correcting this hidden crack doesn't weaken physics, but reveals its true strength. Newton's first law, the law of inertia, is familiar. An object at rest stays at rest, and an object in motion stays in motion unless acted upon by a force. We picture a hockey puck gliding forever on frictionless ice, a world divided into two states: perfect, force-free motion and motion disrupted by forces. Teachers ask us to imagine deep space where a thrown object travels straight forever unless a force intervenes. But in reality, no place is truly free from forces. Even in deep space, gravity whispers. The law, as taught, describes a hypothetical world, a useful baseline, but oddly disconnected from the messy, force-filled universe we inhabit. It's a concept that helps us measure reality, but it's always about an ideal that never quite exists. This version of the law feels like a statement about what isn't happening rather than what is. We're left with a law that seems more like a thought experiment than a tool for understanding the real world. Is this really what Newton intended, or is there a deeper meaning we've missed? Why would Newton, obsessed with real phenomena, start his masterpiece with a law about a world that never exists? The first law, as commonly taught, feels like a preamble, a definition of what a force is, not a law about reality. In our universe, forces are everywhere: gravity, friction, air resistance. Did Newton really mean to ground his system in a fantasy? This interpretation reduces the first law to a mere definition, a stepping stone to the real laws. It leaves us wondering if we're missing something deeper. Was Newton's intention more subtle and powerful than we've realized? The puzzle remains: why build your system on a fantasy? The answer lies in Newton's original Latin, the word quatenus. For centuries it was translated as unless, making the law sound hypothetical. But quatenus actually means insofar as, or to the extent that, a subtle but profound difference. This isn't a minor quibble. It changes the logic of the law. The law isn't about a force-free ideal, but about the real, continuous relationship between force and motion. The mistranslation was an honest mistake, but it simplified Newton's deeper idea. Scholars realized that Newton's law was never about a fantasy world, it was about our own. The quatenus revelation opens the door to a new, more powerful interpretation. Swap unless for insofar as, and Newton's first law transforms. Now it reads, everybody continues in its state of rest, or of uniform motion in a straight line, insofar as it is not compelled to change that state by forces impressed upon it. The law is no longer about an imaginary, force-free world. It's about the real continuous interplay between motion and force. Insofar as is a slider, not a switch. It's about degrees, not absolutes. Any deviation from straight, steady motion is the footprint of a force at work. The law becomes a practical tool. If you see motion change, look for the force. It's not an exception, it's the rule. The persistence of motion and the presence of force are two sides of the same coin. The extent to which inertia is overcome is the extent to which a force acts. This reading dissolves the old puzzle and makes the law dynamic and useful. The first law is now the starting point for all physics, a diagnostic principle, not a hypothetical. It's the foundation for understanding every change in motion. With the new translation, the first law becomes a universal tool for detecting forces. Assume objects want to move straight at constant speed, then look around. Nothing actually does. Every curve, wobble or flutter is a story of force in action. The law tells us every change in motion is evidence of a force at work. A leaf's chaotic fall reveals gravity, air resistance, and wind. The law lets us dissect motion. Inertia tries to keep things straight. Forces bend the path. The first law identifies the presence of a cause. The second law quantifies it. They're not separate ideas, but a seamless progression. The first law makes the second necessary and meaningful. It's not about imagining perfect motion, but about analyzing real complex motion. Every deviation is a clue, a force to be found. The law is now a practical guide for every scientist. It's the true foundation of dynamics. Newton himself used the spinning top as an example. The top is never force-free. Gravity and friction are always at work. The old and less reading would say the law doesn't apply, but Newton showed otherwise. The top persists in spinning, but friction gradually slows it down. The degree to which it slows is the degree to which friction acts. The law, as Newton intended, is a tool for detecting and measuring forces by observing motion. The top's motion isn't about an ideal, frictionless world, it's about our world, here and now. Newton's laws were meant for real, complex situations. The first law gives us a baseline of inertia, not as a goal, but as a tool. It lets us see invisible forces by their visible effects. This deeper understanding of the first law reveals Newton's true genius, unifying the heavens and the earth under one set of laws. Before Newton, people thought the cosmos and the earth followed different rules. The corrected first law is the cornerstone of this unity. The moon's orbit isn't a special case, it's inertia and gravity in action, just like an apple falling. The law tells us every curve in the sky or on Earth is evidence of a force. The second law lets us calculate that force. The law of universal gravitation tells us what it is. The unless translation created a false divide. The true reading unites all motion. Newton's framework is universal, one law for everything. Any deviation from straight-line motion anywhere is the work of a force. This is one of humanity's greatest intellectual leaps. It made the universe knowable. The story of quatenus shows how much language matters in science. A single mistranslation shaped centuries of thinking. Science is filtered through human words, and even the smallest detail can change everything. Rediscovering Newton's original intent doesn't diminish his legacy, it deepens it. The first law is not a throwaway, but the key to understanding the universe. This tale reminds us to question what we know and to value the original words of great thinkers. Sometimes, the grandest ideas hinge on the smallest details. In science, as in life, every word counts.